Hi, this is a differential equation for response question from the year of 2016 from the AB Calculus test. It was number 4 that year. So there's our differential equation. It looks like we're going to do a slope field here for the 6 points indicated. Don't get all excited now and start doing them at other points. So all we need to do, I'm going to do the same thing I did in the last one that I did. I'm just going to make a little 0, 0. I'm going to make a little grid with the actual coordinates. I'm not going to write it on here because that would make this too messy. And then we've got 2, 0, 2, 1, and 2, 2. And then I have to just plug those numbers in here. So when x is 0 and y is 0, this is 0 on top. And when x is 0, that's negative 1 on the bottom, 1 on the top. And then here, negative 1 on the bottom, 4 on the top. Good? Here, I've got 1 on the bottom and 0 on the top, 1 on the bottom, 1 on the top, 1 on the bottom, 4 on the top. So they just have opposite slopes, except for these two that have 0 slope. I'm going to make sure I draw those enough above, or like thick enough so that whoever's grading this can see that. So negative 1 slope, positive 1 slope. And then what does negative 4 look like? I don't know, but it's steeper than that, so I don't think people are going to fuss at me too much. Maybe like that. And then there's positive 4. Try to make those look the same steepness. Alright, that looks good. Part B, let y equals f of x be the particular solution to the given differential equation with the initial condition this. Write an equation for the line tangent to the graph at x equals 2. So, well, I've got the point already, so point is 2, 3, and then I need the slope at this point 2, 3, and it's not in my, didn't do it already, but it should be easy to find. So 2, that's going to be 1 on the bottom, and then 3 squared is 9, so the slope is 9. Using my differential equation, and then I can just write it in point-slope form. So y minus 3 is equal to slope times x minus 2. Alright, and then they want me to use the equation to approximate f of 2.1, which just means plug 2.1 into this. So if I'm actually going to use it, I do need to add that 3 over to the other side. So I can say f of 2.1 is approximately equal to 9 times 2.1, oops, dang it, minus 2 plus 3. I plugged in the 2.1 into my tangent line equation and just added the 3 over to the other side. You can leave the answer like that. You do not, this would have been a no calculator problem, number 4. You do not need to simplify expressions like that once you get it all into numbers. But that's easy enough to. This is 2.1 minus 2 is 0.1, so that is 0.9, so that would be 3.9. Anyway, easy enough. All right. Part C, find the particular solution to the given differential equation, which means actually solve it. So that's, we're going to do our separation of variables thing with the initial condition that f of 2 equals 3. Okay, so I need to do the separating, so I'm always going to have my dy on this side and my dx on this side when I separate. So the dx is going to come over here, and whatever x's I have, that has to stay. So this is going to be 1 over x minus 1 here. And then the y squared has to go to the other side, and I'm going to write that as y to the negative 2. And then I'm going to find antiderivatives each side. Antiderivative of y to the negative 2, I got to add 1 to the exponent and then divide by the new exponent. So that'd be y to the negative 1 divided by negative 1. Of course, dividing by negative 1 is the same as multiplying by negative 1. I don't put the plus c over here. I'm going to consolidate my c's on the other side. That's how we usually do it. And then here, the antiderivative of 1 over x minus 1 is natural log of x minus 1. I don't think they're going to fuss at you too much if you don't put the absolute value signs. Why is it here that the antiderivative is natural log x minus 1, where here, how come it wasn't natural log of y squared? Well, here it's x to the first power. That's why. Alright, so I think this is good, except we want to actually solve it for y equals. So let's try to do that. So I'm going to move the negative sign to the other side. Actually, you want to solve for c? Let's solve for c first. So I'm going to use that initial condition, 2, 3. It is possible to do some algebra, try to get this into y equals, and then use that and find the c. You can do it either way, but I'm going to go ahead and try to do it now. So plug in 3 for y. So negative 3 to the negative 1 is 1/3. So this is negative 1/3 is equal to the natural log of 2 minus 1 plus c. You know what the natural log of 1 is? It's 0. So c is equal to minus 1/3. I'm just going to write that out again. So minus y to the minus 1 is equal to natural log of x minus 1 minus 1/3. Okay, multiply through by negative. So y to the minus 1 is equal to negative natural log x minus 1 plus 1/3. And then y to the negative 1 is the same as 1 over y, so I'm going to just flip both sides over. And when you flip this side over, you have to flip the whole thing. You can't flip them individually because that is mathematical fake news, untrue. So that is my answer.